Okay, good morning again, everybody. Let's get started. So welcome again to the webinar where we're going to talk about equipment effectiveness enabled through IoT. You can see the agenda on the left, but a few intros first. I'm Gavin Morgan and I head up IoT business development. I joined CAD-IT in May last year after working in aerospace manufacturing for over 30 years. And once again, I'm joined by Andrew Howarth, who is our IoT applications consultant. And he's also got extensive experience working in manufacturing, as well as in the electronics and printing industries. So as I said, today's agenda is on the slide. And the aim of today's webinar is to dive a bit deeper into the topic of equipment effectiveness than we have on our previous webinars. For those that joined last time, you'll remember that we introduced this concept as one of the realistic approaches to IoT. And we spoke about why it's one of the good things to tackle first as you embark on your digital transformation journey. We've purposely reduced the number of slides again in this session so that we can do a live demo of this use case in action with our industrial demo unit that we've got connected to the IoT platform Siemens IoT. Okay, just to recap then on our series of webinars on simple IoT. This is the third one, and as I've already said, we'll explore the topic of equipment effectiveness. Some of you may have joined the previous ones where we've explored simplifying the approach to IoT and also condition monitoring. And our next one is where we will discuss energy management, and that's signposted on the slide here. We'll release the date for that as soon as we can. So please look out for it. Advertised through the normal channels, and of course please sign up. So first of all, a quick reminder about the simplified digital transformation journey and where this topic of equipment effectiveness sits along that journey. So we're still talking about the first 3 steps on the journey, and doing these first creates a simpler path to even greater benefits as your people and processes adapt to the change. Reaching for a panacea of a world of AI and machine learning at the far right of this arrow is only achievable if you lay the foundations well in the first 3 steps. So to just tap into those actual use cases involved in the adoption of IoT, it starts with monitoring assets and evolving business processes. And this is before adopting anything like a full digital twin of your products and processes and connecting these digital representations together. So the measure of equipment effectiveness, or OEE as it's known, is an outcome really via an aggregation of various data sets that we'll explore in this webinar. One of these key pieces of data can come from a result of doing the first 3 steps on this journey under the connect and monitor stage. So next we'll look at why our IoT helps make this data set much more trustworthy and increases the impact of the overall measure. Some people might say, well, surely it's just about remote monitoring of equipment through IoT rather than recording what happened on a paper chart next to the machine, which is typically what we see in a lot of organizations. Well, I would say it is that, but it's a lot more as well. And the main challenge with measuring equipment effectiveness is that we need to bring what are quite often disparate data sets together. So the machine can't tell you everything. And today's not supposed to be a theory lesson on OEE at all. But as usual, I like to get us all on the same page. So here's a classic definition of an OEE calculation. Now you can find various different ways of calculating each element of the formula. I wouldn't get too hung up on it. As long as you select the best way that matters to your business and you stick with it to make sure you've got a constant way of measuring it to track over time, you'll be absolutely fine. The most important point to make here though is that using IoT to do this, it can easily be adapted to suit your way of calculating it. So let's look at each element of the calculation in turn. Firstly, availability. It's the amount of time that your equipment or process is running, as it should. It's the percentage of your planned production time that was spent producing. And here's the formula for that. Typically, the top part of the fraction comes from a manual record of how long the equipment ran. And this is very subjective and relies very much on trust from people who are running the equipment. Unplanned losses are not always captured, so we often get an inflated running time. But by using IoT and connecting to the equipment, the actual running time can be captured consistently and accurately all the time. The production schedule at the bottom of the fraction should be cognizant of any planned downtime and therefore not include it. And this tends to be the biggest area of contention. Different people have different views on what should or shouldn't be included in this aspect. Some organizations like to use total equipment effectiveness performance, or TEEP, which uses all available time, i.e. 24/7 times 365. And some use overall operations effectiveness, which is OOE. And this uses all available time, such as 24/5, as there might not be any factory work, weekend working in the factory. They're all fine, but an OEE measure should use all the time that is planned to be available. Therefore, events like planned maintenance, calibration activities on the equipment should be removed from the value representing the production schedule. On to performance. This is the speed of your production process and your ability to stay at that pace over time. So here we are, interested in the ability to produce at the planned rate. The actual number of parts produced typically comes again from manual paper-based tally charts, or perhaps people moving markers around on magnetic whiteboards in factories. If you're lucky enough to have an MES system, the data can be derived from there also. But again, in a lot of organizations, it's typically manually transcribed from whatever system it's recorded in into whatever system is managing the overall calculation, typically Excel, which is inefficient and subject to error. The planned number of parts should be in line with the plan from your ERP system, or at least from a plan that is flowed down from your ERP system. With IoT, you can count completed cycles via connection to the machine, or you can even connect directly to the MES and ERP systems to grab the single source of the truth, if that's what's preferred. And lastly, quality. Well, this refers to, well, the quality of parts and how often you make defects, and it's probably the biggest challenge. It's often the case that at the end of a production cycle, it's not known whether a good part or a bad part has been produced. Exceptions to this would be if the equipment has inbuilt inspection, such as on-machine probing, or perhaps the machine has crashed or experienced an issue and stopped early, which would be an obvious indication of a defective part. But quite often, we have to wait for parts to be inspected further downstream to get this measure, which is what makes the OEE calculation very retrospective in a lot of cases. Again, the data for parts produced would come from manual counts or from the MES system, if that exists. The count of good parts, or should I say bad parts, would come from whatever quality management system is in place to manage non-conformance data. This could be MES again, but it's quite often paper or Excel based at best. With IoT, the data can be automatically collected from files or other electronic databases, making it efficient and consistent. So before we move on to the next section, where we'll look at, a bit deeper into why we should use IoT and a demonstration, here's a summary view of everything we just looked at. And I appreciate it's a very busy diagram. So for those that are interested, it might be a good time to take a screen grab by pressing print screen on your keyboards and then pasting it somewhere you can look at it later. Okay. With that, I'm going to hand over to Andrew, who's going to talk about IoT and give us a live demo. Something that's caught us out. Andrew's having issues with audio on his laptop. It's not recognizing the microphone on his machine for some reason. never happened before, but there you go. That's technology for you, isn't it? So what we're going to do, we're going to skip the demonstration part of this webinar and move to the end, which really is about giving you a chance to submit any questions through the comment section on LinkedIn or the chat if you're watching on Zoom. I appreciate this is very disappointing, and people might have joined to see a live demo, but we will follow up with everybody that's joined with a chance to look at the demo, and we may even record it and send it out as well. So with that, I will give you a couple of minutes to send in any questions via the comments or the chat, and Alison will moderate that for us, and we'll talk about I will talk about them. Okay. I'll leave you to it for a couple of minutes just to send in any questions. Thank you.
So I can see that we've got one question come in already, so I'll start with that one and then we can carry on if there's any more that come in. So the first question we have is, how easy in practice is it to scale, adding new machine connections and update dashboards to show these new machines?
Thanks, Alison. Yeah, good question. So the answer, in very simply, with the MindSphere platform, it's very, very easy. If you have an additional machine, you can connect that very easy. The only constraint might be if your data plan that's supporting your platform can cope with that extra volume of data, but we can check that, before you do it. If people are getting close to their data volumes in their plan, you get warnings, so nothing should catch you out. And if you plan to connect another machine, you can easily plan to upgrade that data plan. And then the second bit is, once you've got that machine connected around the dashboards, then these are very, very easily adapted. So there's no coding skills required. It's very, very drag and drop with widgets. You basically you create a new dashboard, you drag a widget on, be it a pie chart, a graph, a dial gauge, a temperature gauge, whatever widget you want to visualize the data with, and you connect it to the data point that's coming from your machine or your asset that's connected, and the dashboard just works straight away. So very, very easily, very, very scalable, and very easy to adapt for new situations. Okay.
I've got another one as well. How can industry more easily consume this technology / approach? For example, ideally tailored to a sector or process?
Good question. So in my view, and this is only my view, I tend not to differentiate too much between sectors. So overall, it's easy to adopt the technology if your operational technology, so your machines and your infrastructure, is of a reasonable standard that it can connect. Okay, if it can't connect, then there's some investment required to make it connectable. But in most cases, in most situations, we can connect. In terms of whether it's food and beverage, whether it's aerospace, whether it's automotive, whether it's fast-moving consumer goods, whatever, heavy industry, it's kind of irrelevant, because we're just talking about data from equipment. So that could be a 5-axis CNC machine, it could be a brewery line. All these things have control systems on, and they're pretty agnostic to what's actually happening in that factory, in that industry. So in my experience, the technology is very easy to adopt, should I say. The key bit there, adapt, is, the key challenge really is the people and process part of it. So this technology, when you bring it into your business, changes people's lives, and it disrupts things. You might have, guys that have been doing a task for many years, and all of a sudden technology comes along and disrupts that and changes what they've been doing and what they've been used to be doing. So you have to take people on the journey with you. So there's a cultural change and a cultural shift that goes along with this, and that can be harder than the technology shift, or the IT people can install things, and the applications consultants can come and configure things to make things work. But the people and the business process has got to adapt to work with that new technology, and that's probably the toughest challenge, I would say.
And another one, what dependencies must be considered for enabling IT and essential data management / security?
Okay, another good question. So let's tackle the security bit first. It's very easy to talk about, we just connect and get the data to flow. There's the MindSphere platform. So I know I keep talking about MindSphere, and that's the platform we are licensed to talk about and sell and deploy to customers. It's fully encrypted end to end. It uses all the latest, it conforms to all the latest cybersecurity standards. There are incoming and outgoing ports from gateway devices that are completely segregated, so one cannot talk to the other. So from a security aspect, it is as secure as it can be. It's probably more secure in the cloud than if it was on your premise, because it's manned 24/7, 365. The security aspects of the operating system, the hardware, etc., are all updated to the very latest standards automatically. So there's no overhead from managing your own infrastructure there and supporting it from that perspective. Alison, can I go back to the first part of the question, and I tackled security, which was at the end there?
Sorry, and then just another one. What cost models exist which we can evaluate today for full life cycle ownership of these technologies / platforms?
Cost models. Okay, I'm not too sure I understand what we mean by cost models. So all I can say about costs at the moment, if whoever submitted that question can elaborate, then I'm happy to discuss it further, but I'll talk a little about cost and cost of ownership. So the MindSphere platform, pretty much, if you go for the cloud option, which is this kind of primary approach here, it's very much like owning a mobile phone plan. So you subscribe to the platform, and you pretty much pay for how much data you want to shift around. So how much data do you want to transport from your business into the platform, and how much computing power do you want to use to analyze that data? And that's pretty much how your subscription works. And if you want to increase that, and then you've got certain limits, and you might have to upgrade to the next plan, very much like a mobile phone plan. So that would be an ongoing recurring cost. Other than that, sort of one-off costs at the beginning would be around gateway devices that would need to be attached to your equipment or into your existing IT infrastructure. And if there are any sensors that don't currently exist on your equipment that you want to retrofit on and then connect through to the platform. So there are some upfront costs that are one-off, and then there will be a recurring subscription cost. Obviously, if you went for the option, lots of different businesses such as defense, MOD type restrictions recur around that, where you're not allowed to put data in the cloud, so you have to go on premise. Well, then your costs do go up quite considerably because of the infrastructure you have to invest in. Okay.
Gavin, can you hear me okay?
Yes, hello, Andrew.
Hello. So first of all, apologies, everyone. I have no idea what happened. I think it was an update to Zoom in the background. The only thing that fixed it was restarting my machine, which I didn't do straight away. I was trying everything else that I could do. So apologies for that. So first of all, I can just add to that question and put another perspective on, but also if you want to stay on, I can also do the demonstration now, because I'm sure that might bring some things to life a little bit. But just to answer the question about cost models, so just taking a different perspective in terms of how IoT, and in particular the use of OEE, can help business cost models and affect business cost models. If you take, for example, the use of IoT of OEE in the facility, in a factory, in manufacturing, this OEE KPI can help you compare asset performance and the effectiveness of those assets, and that can be used to both inform your updates and upgrades of existing machines, but also capital expenditure on replacement of machines. So if you've got and Gavin talked about this earlier, a very consistent and effective OEE KPI that you're using across many assets within your facility, then that KPI alone can be part of the sound data-driven reasoning that allows you to determine where to make investment in your business. And that's one of the real powerful points of using equipment effectiveness and OEE as a KPI. Where IoT helps with that is, of course, generally you can connect more assets more easily, you can scale out more easily across the assets. But then, of course, the using the power of the internet, that information can be accessed remotely and in many different locations, rather than just at a machine tool that has an equipment manufacturer's own OEE system embedded, which tends to be more difficult to scale and upgrade without changing software. What IoT gives you is the ability to more easily scale, add more assets, add more data points, and of course, change your dashboards to suit your business, change your KPIs to suit your business, and access those data visualizations and KPIs pretty much anywhere. So that's how the two fit. That was something I was going to talk about earlier anyway. So if there's more questions, we'll take those, but otherwise I can go straight into the demonstration if that helps.
We've just got one more question, so I'll just do this one and then you can go into the demo. To what extent does the Siemens MindSphere platform leverage other Siemens portfolio products?
Do you want to take that, Andy? Or?
Yeah, okay, yeah. So across the actual product range, so first of all, if you look at connectivity, which is one element of IoT, so there are many industrial gateway devices, Siemens devices, that can be deployed to connect to machines and assets to consume the data. There's also MindConnect software, which can be deployed on Windows machines to talk to applications. So this is part of the Siemens hardware and software portfolio. And then of course you've got other Siemens applications such as Op Center, the MES, PLM systems, all of which the IoT capabilities allow you to talk to and consume data. So the ability to effectively integrate or even interoperate those database systems, software applications, hardware devices is all possible through the Siemens portfolio. But ultimately, the power of a good IoT service is that whether it's Siemens or another, is that these devices and applications can be connected, whether it's Siemens or not. Okay, so if that covers the questions, let's have a go at the demo. So let me just share my screen.
Yeah, there you go.
Good, okay. So as I was saying, this application is one of the applications that most readily enables OEE straight out of the box. Once you've connected assets, the data from those assets plug into these visuals. But these OEE dashboards and visuals could also be constructed in other applications to be more flexible to suit your business need or your preference in terms of visualization. So what we'll do today is just talk about the Performance Insight app, but as I said, this could be constructed in many different ways. What you're actually seeing here is a tree on the left-hand side, which represent a number of different assets. Now, not all of these have an OEE dashboard configured in this application. They're all available assets that are connected to this MindSphere platform. But the ones with the symbols to the right-hand side there with the gauges are the ones that actually have OEE dashboards configured. So they have the assets plugged into this application. What we can do first and foremost, if I go on to this individual asset and I look at the time range, this is currently looking at today. What you're seeing, first of all, at the bottom of the screen is a very simple machine status for this asset. And that machine status is broken down by the actual planned downtime for that asset. So that could come from, it could come from a spreadsheet where you've said this asset will be down between midnight and 6 in the morning every night, and or it could be maintenance schedules that occur on a regular basis. They are planned downtime that feed into the OEE calculation so that it understands that that isn't planned production time. So it takes it off the actual overall production calendar to calculate availability. That also on that machine status view, you can see the unplanned downtime. So obviously this is when the asset is not running, but also not planned to be running. And then of course in green there, we've got the actual net production time. So what that gives you is a very simple visual and breakdown of the time it's spent in these different statuses. And this is coming directly from a status that's being calculated within MindSphere. But what's really important is we recognize that not always do the machine tools provide a status to say I'm in planned downtime or I'm in unplanned downtime. That information might need to come from multiple sources. So it may be that the machine can tell you when it's on or off, but you actually need to determine when it was planned to be off from another source. And that could be your spreadsheets, it could be other maintenance systems where you manage your maintenance calendar. Or it could be a production manager's schedule. So there's many different ways, and that can be plugged into this to give you an accurate breakdown of the actual planned production versus unplanned production. So that status overall feeds into the availability widget there on the dashboard. So you can see here we've got a percentage availability calculated over this date period. And we can just see a trend there of that this has actually gone up since the previous day. So we've got 32% on the previous day, we're now at over 78%. So we now understand how much availability we have for this asset. The performance metric allows us to understand whether the machine is actually performing at the rate we expect. So is it producing the number of products at the rate we expect? And that's coming from a separate feed, which could be an MES system, it could be another system where you record how many products are being produced. And that will give you a number of products produced against a desired number of products for this asset. You can see there a percentage calculation of performance. It's not quite running at the high expected rate that we expect from that machine. And that could be simply due to not running the machine fast enough or other issues with the machine's output. Of those products being produced, you'd also want to ensure that those products are right and can be shipped to customer. So another important part of the OEE metric is the quality of the product. That is my product good or is it bad? Does it conform? Does it not? So there we can see the product quality is at 75%. So all the products being produced, only 75% are good. And all three of these KPIs sum up into the OEE metric as per the calculations that Gavin described earlier. You get a very good, consistent metric. And if this is applied across many machine tools, you can then also compare machine tools. And I'll show you a little graphical image of that in a moment. With all of these, you can also drill down. So you can look into the data and see the trend lines over time. So I actually switched on the unit that's plugged into this morning. You can see prior to that, there was no data being fed in, but you can see the different KPIs and the comparison of those during this schedule. And then we've got other metrics, such as a histogram of that data and the various statistics, and then a time comparison of the OEE, the availability, performance, and quality. You can quite easily compare with these very simple but easy to consume visuals. So I mentioned earlier about comparing assets. I'm currently on one of the assets that's connected in the tree. If I go to the sort of factory level, almost the parent asset level, I've got an additional option here that knows that I have 2 assets configured, so I can see an analysis of sub-assets. So I can now start to compare. Now you can see at the moment, one of the assets, which actually my PC, which is running a software agent, probably why it crashed earlier, because it's doing a lot of things. This asset is actually not producing any data recently, but if I go back 30 days, the last time I was using that software, it is a simulation, of course. You can actually see now, well, there's 2 assets connected, and I've got some machine status, some differences on when the machine's on and off, and obviously this one has actually been configured to show planned downtime. You can see those differences, and then you can see these 2 assets and the KPI scores, and you can very easily compare them. So if you have a number of them, it's easy to see which one has the worst OEE. And then from here, you can drill down to where I started earlier into the individual asset. Now we're still at 30 days, so now you can see a more detailed breakdown over that 30-day period of when this machine's been running and not, and when it's been planned not to be running. The other metrics in this screen you'll notice on the right-hand side is TEEP, MTTR, and MTBF. These metrics have some differences to OEE in that TEEP effectively uses the overall calendar. It's not your planned production calendar. It's the overall time available for that machine to run. So it doesn't include planned downtime or when you actually plan to run the machine. It's purely how much capacity is available. So that gives you a much lower OEE score if you are only running 2 shifts and you have a number of maintenance schedules. So you only actually run the machine a certain percentage of time. You could actually use that metric to determine that if you made some changes within your business, you've got more capacity, so you could increase productivity. So that might be helpful using this metric to determine, well, maybe we don't need to buy new machines, we just need to get more out of the ones we've got by utilizing them more. And also, of course, which machines could you actually get more out of by comparing them. MTTR is the mean time to repair. So when a machine has been in unplanned downtime, maybe due to a failure, how long does it actually take to typically get that machine back into production? So an average score of the time it is in unplanned downtime. And then the final one, mean time between failure, is how, on average, how long that machine typically stays in production and is available to run. So that machine is not in any error state or in unplanned downtime. It's actually ready to run and available to running and is able to produce products. So from a maintenance perspective, though, these can be very useful to determine which machines are the most problematic and have got health issues, asset health issues that might need addressing. And that can obviously be used to compare other machines to determine which machines might need some investment to bring them back up to a certain standard to be productive. So you can investigate further with that KPI and that measure. Okay, so that's the very simple KPI dashboard and the metrics there that you can see and the breakdown of machine status. One other thing you can do with all of these dashboards, you can add additional dashboards that are meaning to you and use the data that's coming from the asset. So what I've added here is an hourly production record. If I change this to, let's say, the last 14 days, what we'll be able to see here is a rate of production, so when this asset has been switched on and producing products. And what is that rate and what's the breakdown of that rate? Of those number of units produced, how many in a percentage were good and how many were bad? And then you can see here from this, there's sort of an alert on the dashboard that there's too many bad products against a limit that I have set. And this can also trigger an alert or a phone or an email or both. So that's effectively breaking down the quality metrics so you get a more detailed view of your production rate, which can obviously be used to determine whether you're able to deliver the volumes or are delivering the volumes that you expect, or if there's any issues with quality that need to be addressed. And you can add further dashboards onto this to put more visualizations using the same data sets from the assets, building derived calculations from those data sets to build a view that's important to your production team or to your management team. There'll be different perspectives, and that ultimately is one of the powers of having these scalable dashboards, is you can tailor them to suit what teams and individuals need to be able to see to address issues from their perspective. Okay, so that was the long-awaited demonstration. I hope it was worth waiting for, and apologies again for the technical issues. Obviously, they do happen, but I hope it was worth waiting for the demo.
Thanks, Andy. Thank you very much, and well saved. Okay, so thank you everybody for sticking with us. Apologies again for the gremlins. So last thing just to say before we wrap up for the day is that we'll reach out to everybody that's joined today and offer you a free one-day consultancy if that's what you think would be useful to you. We can do a more detailed demo in context of your business as well with our demo unit. And we can do this remote or we can do it face-to-face. But we'll be reaching out to you, so please get in touch if you want to have further discussions about the technology or anything you've seen today. Okay, and with that, we will end the session. Thank you once again for joining and thanks for sticking with us.
Thanks, everyone.